Hello, hello, hello. Chapter 2, 2.2. Notice how we don't start with 2.1 because you're so amazing. We don't need to do 2.1. First, talk about relation and function. A relation is when there's any two set of corresponding numbers they have some sort of relationship with. A function, a function is when every input has one output. A function, exactly one item. So the input has exactly one item. Basically, it comes down to the x's. The inputs cannot repeat. So let's look at question number 1. The input value of x is the number of representatives from a state, and the output value is the y of the number of senators. Well, this is where you have to know your judicial branch. Did I say that? Maybe one of you will be able to correct me. But senators, when we're talking about senators, every state has two. So really what this is saying is that this would be an equation where it doesn't matter the input, y is always equal to 2. If we were to graph this, it would be a line like this. This is the equation or the graph of y equals 2. So every input, every x value has one output. So yes, this is a function. Yes. If I look at 2, oh, right away. Bing, bada, boom. No, not a function. Those two repeats. I don't care about the y's that repeat. I'm looking at the x's. The last one, if I do my vertical line test, it's always a little bit easier. None of those x's repeat. So yes, that is a function. So which one of these represents a function of x? So first thing we want to do is set each equation equal to y. Pause the video and rewrite both equations equal to y. Now you could graph these on your graphing calculator if you wanted to. They should look something like this. So if I look at this, is this a function? Yes, because every x value has one y value. Is this a function? No, because if you were to plug in a certain number like 3, you'd have a positive negative 3. Would have two different answers. So 3 would show up two different times. So this one is yes, this one no. Next one, evaluating. I'm going to do the first two, and then you're going to do the next two. Whoa. So this is just saying, remember, here's my function of g. This is telling me that x is equal to 2. X is equal to 2, so anytime that there's an x, I plug a 2 in. Now, making sure that you plug it in correctly, and then if I put that into my calculator, I get 5. So if I asked you to rate this as an ordered pair, that would be my answer. Here, I started with a number, I got a number out. That was my answer. Here, I'm starting with an x. My answer should have an x in it. So when I'm rewriting this, I have opposite in parentheses, this x minus 1 squared plus 4 times x minus 1. Anytime you see that input spot, you plug this into it. Now this is where I'm going to have to FOIL the x minus 1. Remember, when you say something is squared, it's saying that it's multiplied by itself. So if I FOIL this, we have that negative 1. This would be my first outside, inside, less. If I distribute this 4 in, I get this. Now I have to distribute this negative to all of these terms, so I have negative x squared plus, this is actually a negative 2 right here. So when I distribute this negative, this becomes a plus 2x, this becomes minus 1, and now I can combine like terms for my final answer. So I'm going to have that in standard form, my negative x squared. Here's 2x plus 4x would give me a plus 6x. 1 minus 4 would be negative 5, plus 1 would be a negative 4. So right here would be my final answer. I want you to pause the video and try to do C and D by yourself. For the first one, you should have got negative 4, negative 31. Here, sometimes people get confused. When you are squaring this, this becomes 2 times 2 is 4, x times x is x squared, and that's my simplified version. Now we have a piecewise function. So now we have to look at our domain. This is saying use this equation if x is less than 0. This is saying use this equation if x is greater than or equal to 0. So if I'm asking for these three numbers, for this equation, I'm going to evaluate where x is equal to negative 1. Not 0 though, because this is or equal. This equation, I'm going to evaluate where x is 0 and 1. If I plug negative 1 into the equation, negative 1 squared is 1 plus 1 would give me 2. If I plug 0 into the equation, 0 minus 1, again, because this is the restriction, 0 minus 1 is negative 1. And if I plug 1 into the equation, 1 minus 1 is 0. So that would be my answer. Pause the video and try to do the next one by yourself. And you should have gotten those 4 answers. For this next one, it's saying find all real, so I'm not dealing with i's right now. So this is actually a review that we have been doing. So it's saying if f of x is equal to 0, so set this equation equal to 0 and solve. So I'm going to pause the video and you should be able to set this equal to 0 and solve. Here you should get x equals 5. Here if I factor, it should be -2 and -3, because again, these have to multiply to get a positive 6. You should get 2 and 3. So again, this is kind of review. It's just giving it to you in a different format, saying the function of f equals function of g. There have been plenty of times where I've given you problems, and this is how it began, and you have to solve. For now, I want you to try to do a and b by yourself, so solve this equation. Pause the video if you need to, but the first one you should get x equals to 1/2 and 1. The second one should be 3/2 and -1. For example 7. Now I'm asking for the domain of each function. Remember, domain, I'm just asking for domain. Domain is what values x can be or what values x cannot be. So because I have this as a list, I'm going to actually just list it out. Now when we list it out, we typically do it in numerical order. And actually these are already in numerical order, smallest to largest. So my x values are -1, -3, 0, 2, and 4. Now here, this is, instead of saying what x can be, it'd be easier to say what x can't be. Remember, we can't divide by 0. So x cannot be equal to -5, because if it was -5, that'd be 0. So my function of g, domain, would be x cannot equal -5. Or if you wrote it as interval notation, it would look something like this, saying it can be everything but -5. I want you to try to pause the video and do the next 2 by yourself. So here, because we're talking about volume, the radius has to be greater than 0. So it could be like this, or interval notation like this. Here, when you take the root, you can take the root of a 0, and not anything less than that. So it can be equal to 0. So if I solve this, it can be anything larger than that, but nothing below. These last 2 questions, oh my gosh, words, they're scary. We're going to do these in class. So that's all I have for you for 2.2. Have a wonderful, great, grand, wonderful day.